Today we're going to talk about our first conic section, the circle. A circle is a figure composed of points equidistant from a fixed point, the center. So you might want to pause and get that written down, and then we'll go on. We are going to label the center of our circle H, K, and we are going to label a point on the graph over here, and we're going to call this X and Y. So this XY represents any point on the graph, and all the points are the same distance from the center, and that distance we're going to call R. That's the radius. Now I want to come up with an equation for this circle. So let's make a right triangle here. If I were to drop this line straight down, we have this little right triangle. What would be the coordinates of this point? Well, notice this point is the same distance up as the point HK. So it would have the same y value. It would have the y value k. And has the same value, x value, as the point directly above it, h, xy. So this would have the coordinates x, k. Okay, so this is hk, xk, xk, xy. So if we wanted to know the distance between the point HK and the point XK, we would just have to subtract x minus h. So the distance here would be x minus h. And actually I'm going to make this a little bit bigger picture of this triangle here so we can see this a little more clearly. So if this is R, and this is the point x, HK, and this is xy, and this is xk, this is xk, then this distance here is going to be x minus h. And this distance here is going to be y minus k. So this is the difference in the x coordinates that have the y coordinate k here. This is the difference in the y coordinates that both have the x coordinate of h. And then we're going to do what we've done so many times in this course. We're going to use the Pythagorean Theorem. This is a right triangle, so we know that this has to be true. X minus h squared plus y minus k squared is equal to r squared. And that is the formula for a circle, with its center at hk and a radius of r. This is known as standard form of the circle. Standard form makes it very easy to graph, because using this form I can easily figure out what the center and the radius is. Now if the center were at 0, 0, so if the center hk is equal to 0, 0, then the formula would just be x squared plus y squared equals r squared. So that would be a simpler equation of one centered at the origin. And you might remember when we did x squared plus y squared equals r squared in our previous unit. That was one of the ways that we transform back and forth between polar and rectangular. Same thing. We keep doing it over and over. Okay, so given this equation, the standard form of the equation, x minus h plus y minus k equals r squared, let's write an equation for a graph. So what we want to do is identify two things, the center and the radius. Okay, so this has a center of 1, 2, 3, that looks like 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. So it has a center of 4, 5, and the radius is equal to 1, 2, 3. So I would write the equation as x minus 4 squared plus y minus 5 squared is equal to 3 squared, or 9. Notice I'm subtracting the coordinates of the center from x and y. So basically subtracting, so whatever makes each parenthesis equal to 0 is the value of the center. So when I make x4 and y5, that would make both of these 0. That would give me the center. Okay, now pause it and you try this one. Can you write the equation for this one? Okay, I'm assuming you have done so and unpaused it. So this is -1, this is 1, 2, 3, 1, 2, 3, 4, negative 4. So it looks like my center is negative 1, negative 4. My radius is 2. So the equation would be x plus 1 squared plus y plus 4 squared is equal to 2 squared, or 4. Okay, the next piece would be, now that you have seen how this works, can you draw a graph given the equation? So first one, I need to identify the center. So when I look at this equation, the center is at positive 2, negative 2. So positive 2, negative 2 right here. The radius is equal to the square root of 16 because r squared equals 16, so the radius is 4. So then I'm going to count 4, 1, 2, 3, 4, in every direction, up, down, left, and right, from the center. Does that look like I've done 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, then what I suggest you do is start on the left and kind of make an upside down bowl like that, and then start on the left and make a right side up bowl. It's easier, I think, to make a neater circle if you do one half at a time than try to draw the whole thing at once. It still takes a little practice. Okay, why don't you pause and do this one yourself, and then turn it back on and check that you've done it right. So I see here that the center is at negative 3, 0. Negative 3, 0. And the radius is the square root of 25, which is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then once again, curve around. Curve around. That's not too bad, actually. Okay, so that is being able to draw a circle and write the equation of a circle, not terribly difficult. I think I'm going to stop the video here and then do the second side. We'll do the completing the square on the second side as a separate video.